All right, good afternoon, everyone. My name is Jacob Casey, camera. This is my audience. So does anybody know what this circuit diagram is depicting? And don't feel bad if you don't. No one? Okay, so this circuit diagram is depicting a variable frequency drive. This is something used in almost any industrial alternating current motor circuit that you will find. It's very important because it allows for AC motor soft start and motor variable speed. It is extremely important to our location in particular because we have a lot of equipment on our machines that is expensive, and this allows us to control its speed without physically damaging any components. So the first thing that we will discuss within this topic is frequency. We're going to discuss frequency because it's a very, very important concept, and actually the key concept on how a variable frequency drive controls motors. Frequency is the number of times that alternating current goes from a positive voltage to a negative voltage in a second. So for common 120 volt American household electricity, you're going to see 60 hertz, which means it's going to go from positive 60 volts to negative 60 volts 60 times within a second. And the 60 volts, that just applies to 120 volt power, but you know, if you're using 480, then your phases are going to go up and down to a different voltage. So again, frequency is very important. Now we'll talk about induction motors and the role that they play in the system. An induction motor is the specific type of motor that a VFD can control. It does this due to the stator, which is a set of windings where they are alternating and wired into each of the three phases of this AC circuit. On the inside of these wires and what they're windings and what they're wired to are electromagnets that essentially are energized in opposite polarities as the phases change voltage. And what this does is, as the rotor is slid into here, they'll energize, let's say, on a positive polarity, which will drive the rotor a little bit, a negative polarity, which will pull it, positive polarity, so on and so forth. In summary, that is very important because now we know how a VFD controls a induction motor, and we can move into the specifics of what it does with the electricity in order to enable itself to do that. So the first step in this process is the AC to DC converter. Many people don't know this, but the VFD drive works all of its magic in DC power and then outputs AC power. So it converts the alternating current to direct current by use of diodes, which are basically check valves, if you could correlate it to plumbing. It allows the current to only flow in one direction. So as each phase comes up in its sine wave and overtakes the last phase, it's going to output some voltage at that point. So for a 480 volt AC circuit, when it goes to the AC to DC converter, it's going to end up at around 650 volts DC. Now with that being said, it's going to be very choppy, so it's going to need to go through the next component to be cleaned up. But just to go back and summarize what we talked about here, in this first component, we're just converting alternating current to direct current. Now we'll move on to the DC bus. I know it says DC link right here, but that is actually the DC bus. The DC bus uses a capacitor to clean up the kind of flapping AC current or newly formed DC current. Capacitor basically stores potential voltage and allows the DC bus to draw out of that storage on when it needs to fill those gaps in the newly formed DC current. Just to clarify, capacitors are probably one of the most dangerous components that you'll find in your household. because when you think of de-energized something, you may not actually have. So to summarize that component, all it does is clean up that DC power so we can work with it. The next and last component within a VFD is the DC to AC inverter. What that does is it outputs that direct current back out to alternating current at the frequency that the VFD desires. The way it does that is switches, we'll call them switches, they're actually transistors wired into two diodes, but these switches choose whether to output positive voltage or negative voltage. So what they can do is say it wants to output 1 hertz, which we remember 1 hertz is 1 positive 60 volts to 1 negative 60 volts in a second. So let's say it wants to output 1 hertz. Well, they'll all switch over on one phase. They'll output a high for 30 seconds, and then they'll all switch over and they'll all output a low for 30 seconds, right? Which will give you 1 hertz of alternating current output to the motor. At that point, your motor's probably just going to be humming because it's not polarizing those magnets fast enough to actually spin the motor. It is important to note that this will come out in a rectangular waveform because these are not variable potentiometers, they're just switches, so, or variable resistors. They're just switches, so it's either positive or negative. But motors do not care. They will eat up a rectangular waveform all day, whereas your household components, they will care. So in summary, the DC to AC inverter just outputs that DC back into AC at the frequency that is required to make the motor drive at the speed that we want it to drive at. So in conclusion, VFDs are very important to industrial applications. They're very important to our facility. Not a lot of people understand how they work. They just see it as some magical box that somehow controls the speed. And I even found myself testing voltage on the bottom end of a VFD the other day, which is what sparked my interest to try to learn some more about this subject.